In this lesson, we're going to be looking at geometric sequences. This is section 8.3. So we've already looked at arithmetic sequences, so let's take a look at a geometric sequence. It's defined to be a sequence whose consecutive terms that are right after each other, have a common ratio r. The common ratio is r. So arithmetic sequences have a common difference, d, but for geometric sequence, we have what we call a common ratio r. So common ratio of this sequence. So we have notation here. It says take the second term and divide it by the previous term, or term 1. And when you divide, your quotient is r. So when you take the third term and divide it by the preceding term, the second term, and you do that, and you get a quotient, and it's also r. And then if you keep going and you take the fourth term, divide it by the previous term, the third term, and your same quotient is r. Okay, and if this pattern continues, then we have what we call a geometric sequence. So example 1, determine whether the following sequences are geometric. If so, determine the common ratio r. All right, so according to these formulas up here, I might start with taking a sub 2, dividing it by a sub 1. So this is a1, this is a2's value, a3, etc., where this is position 1, 2, 3. So a2 is 125. And I'll stack it on top of 625. You can start dividing out 5s, but when you simplify this, you should get 1/5. Well, I haven't established that this is a geometric sequence yet until I take several consecutive terms and get the same common ratio, or the same quotient. So let's look at a sub 3 now and divide it by a sub 2. So a sub 3 is 25, and a sub 2 is the previous term, 125. You reduce this fraction, you do get 1/5. Okay, just to feel comfortable, I'd probably do another set. So a sub 4 divided by a sub 3, so 5 divided by 25. Okay, it appears that the suggestion is that I'm always getting a quotient of 1/5. So the common ratio is 1/5. Which means if you go back to 625 and you multiply it by 1/5, we're not adding or subtracting. This isn't common arithmetic. This is geometric, which means multiplying. If you take 625 and multiply it by 1/5, you're going to get 125. If you take 125 and multiply it by 1/5, you're going to get a smaller number than 125, and it works out to be 25. 25 times 1/5 gives us 5. 5 times 1/5 gives us 1, so forth and so on. So example B, let's determine if this is geometric or not. So again, this is A1, A2, A3, A4, A5. So I'm going to take A2 divided by A1. So that's 10 divided by 4. And that simplifies to 5/2. Then I'm going to take A sub 3 divided by A sub 2 and find that quotient. So 18 divided by 10. Divide a 2 out from the top, you get 9. 2 out from the bottom, you get 5. And 9/5 does not equal 5/2. So you're out of this problem. This is not a geometric sequence. Okay, so just note, not a geometric sequence, so there can't be a common ratio, not geometric. Okay, most of our attention in the rest of this lesson wants to deal with geometric sequences. So what we have here is we have a formula for the nth term of a geometric sequence. So a subscript n is equal to the first term times the common ratio, whether they give it to us or we find it, raised to a power of n minus 1, where r is called the common ratio. In example 2, we're asked to write the first 4 terms of a geometric sequence where the first term is 4 and the common ratio is -3. Okay, what we're being requested to find here is the formula for the nth term of a geometric sequence. So that would be this equation right here. This is an additional formula that you guys can have on a piece of paper when you go to take test 4. All right, a sub n is equal to a1 is 4. The common ratio is -3. Go ahead and use parentheses around that common ratio, and then let's raise this to the n minus 1. And you could put n minus 1 in parentheses if you want, or not. So what's the first term? Well, by inspection, I'm just going to multiply 4 times -3, and I'm going to get -12. Then I'm going to take -12 and multiply it by -3, and get positive 36. Then I'm going to take 36 and multiply it by negative 3 to get negative 108. You keep multiplying by the common ratio to generate terms. But if we're going to use a formula to get those numbers that we think we should have, I'm going to come up here to this formula. A sub 1 is equal to the first term, which is 4, times the common ratio, negative 3. And where 1 is, okay, I would have 1 minus 1. So without a calculator, I could do this. 1 minus 1 is 0. I have to do the power first. I cannot multiply the 4 into the negative 3 because that's not following the order of operations. So negative 3 to the 0, anything to the 0 is 1. 1 times, 1 times, wait a minute here. Yeah, the first term, sorry. Yeah, that's 4. That makes sense because that's a sub 1 and I should get 4. The second term is here. So when n is 2, 2 goes here, but we still have the first term, common ratio, and then this becomes 2 minus 1. So that's 1. Negative 3 to the first is just negative 3 times 4 is going to be negative 12. So we can see that 4 times negative 3 would produce negative 12. The next answer, a sub 3 term, is going to be positive 36, but let's use the formula. So a3, 3's here. First term, common ratio, and then I raise it to the 3, or n, minus 1. You can use parentheses or not. Just be careful with the order of your operations, whether you're doing it mentally or on a calculator. So negative 3 squared has to take place first. So go to the calculator if you want, but that's 9. 9 times 4 is 36. All right, the fourth term, first term, common ratio, 4 minus 1. So negative 3 cubed is negative 27 times 4, and use your calculator, negative 108. So write the first 4 terms. This is what it looks like. Notice that this is what we call an alternating geometric sequence because the signs are alternating. Starts out positive and then goes negative, etc. All right, example 3, write the first 4 terms of this geometric series. Here's the geometric sequence, excuse me. Here's the first term. The common ratio is a third. So because the common ratio is a number less than 1, okay, that means that the values of all our terms are going to get smaller and smaller and smaller. All right, so what's the formula customized? A sub n. What's the first term? 24 times the common ratio, 1/3, to the n minus 1, with or without parentheses. First term, I can go straight to 24 or I can use my formula. So my formula is 24, 1/3. Because n is now 1, I put 1 here. That's 0. 1/3 to the 0 is 1. 1 times 24 is 24. Okay, how do we find the second term? Well, the new exponent is 1. So we multiply by 1 common ratio of 1/3. So this becomes 24 times 1/3. So you can divide out and you're going to get 8. Let's look at the third term. First term times the common ratio raised to the 3 minus 1. Certainly you can do this on your calculator and you're probably going to get a decimal, but I'm a little concerned about my math lab and its specificity, I guess. So calculator's fine. You know how to do this on a calculator. Just make sure and put 1/3 in parentheses and then your little caret key raised to the second power, then go back and multiply by 24. But let's say that you're requested to give a fraction answer. Okay, so this is going to be 24 times 1/3 squared. Okay, now I do the power first. When you square a fraction, you have to square the numerator and the denominator, so 24 is kind of on hold. 24 times, if I apply the square to the numerator and denominator, 1 squared is still 1 and 3 squared is 9. So to avoid the decimal issue, if you're requested to report your answer as a fraction, you'd have to go through this work. Now, this is 24 times 1/9. Okay, so you could look for a common factor. So 9 goes in, or 3 goes into 9 3 times, and 3 goes into 24 8 times. Finish multiplying the numerators together, finish multiplying the remaining denominators together, and that fractional answer would be 8/3, which if you used a calculator, I think is 2.6 repeating. Right, what about the fourth term? Well, that means I have to multiply this term by a third. My answer should be 8/9. If I multiplied this fraction by the common ratio 1/3, I would get 8/9. Let's see if that happens to be the answer when we use the formula. So the fourth term is 24 times 1/3 raised to the third power. So you're multiplying by 3 1/3. All right, calculator, no problem. Take 1/3 in parentheses, raise it to the third, go back then and multiply by 24, you're going to get a decimal. If you want a fraction, okay, then we're going to have to do the power first by hand. So 24 times 1/3 cubed. I'll work out here to the side. So it's still 24 times cube the top, cube the bottom. So that's going to be 1. 1 to the third power is 1. 3 cubed is not 9, it's 27. Make 24 a fraction by putting it over 1. Look for something that'll divide out to make your number smaller. So 3 will divide into 24 8 times, and 3 divides into 27 9 times. Finish multiplying the numerators, you get 8, and the denominators, and you get 9. Which is what we should have gotten if you multiplied the previous term, 8/3, by a third. So just want you to be prepared for it in case you have to give fractional answers. All right, let's see what's happening down here. Use the formula for the general term, the nth term of a geometric sequence. Got it. We're going to be using this formula. To find the indicated term of each sequence given the first term and the common ratio. Okay, notice that this blank, you're being requested to find the formula. And we know we're requested to find the formula because n is just the general term. So a sub n is equal to the first term, 4. I'm always multiplying by -2. And then the formula says raised to the n minus 1. So we insert the first term of the common ratio and we leave the n in the exponent to match that n. Now let's find the 12th term, which means you're multiplying 4 times -2 11 times to get the 12th term. So -2, take the 12, plug it in here, 12 minus 1. And I'm just going to write down here the final answer. So I'd go to my calculator, take -2, make sure it's in parentheses, -2 raised to the 11th power, and then go back and multiply by 4, and the result should be -8,192. Example 5, we want to find the 20th term, given that this is the first term, and we continually multiply to generate new terms of the sequence by -1/2. Okay, so the formula is the first term, parentheses, common ratio, n minus 1. Insert 20 for n. Now, certainly you can go to your calculator. Don't forget parentheses around -1/2. Raise it to the 19th power and then multiply by 8,000. You're going to get a really small decimal. Okay, so that decimal answer, I'll go ahead and report it over here, would look like this. But then again, what if you're requested to give a fractional answer? Okay, well, to do that, my approach would be this: 8,000 -1/2 to the 19th power. I'm going to write down again. So I'm going to tackle this right here first. I'm going to keep the 8,000 on hold times -1 to the 19th power would be negative. That's an odd number of negatives, -1 over. Then I would go to my calculator and I would find 2 raised to the 19th power. 2 raised to the 19th power. Woo! 524,000. 24,288, and then equals, okay, and then here I would look for some common factors to kind of simplify this. I hope that these numbers aren't this large. Okay, before I simplify, because I know both these are even, so I can take a 2 out and possibly a 4. It might take me a while to simplify this, but I know that I'm going to end up with -8,000 over 524,288 before I have to start simplifying it. So like I said, I could divide 2 out of the top and bottom, maybe even a 4 out of the top and the bottom. And you just keep dividing out. If the numbers keep, you know, the numerator and denominator keep being even, then at least you know you can keep taking 2's out. It seems kind of tedious, but I'm just getting prepared for what if you're asked to report your answer as a fraction, okay? And I don't have this final answer simplified all the way down. But you know it's all the way simplified when you change it to a decimal and you get that value right there. So hopefully we won't encounter something that has those large numbers. Okay. These are the same kinds of questions, but now they don't straight up give us the first term and the common ratio. It looks like we might have to do a little more work. So write a formula for the general term, then use that formula to find the 7th term. Got it. So we know a sub 1 is 3, and then we have to figure out what is the common ratio. Remember, we take 2 consecutive terms. We take the second of the 2 that I've circled and divide it by the previous one. So 15 divided by 3 is 5. Then take and at least do the next 2. What's 75 divided by 15? It's also 5. So it appears that I keep multiplying by 5s to generate the next term. So my common ratio is 5. It would be negative if the signs were going and switching from positive to negative, etc. But right now it looks like the common ratio is 5. So the formula is the first term times the common ratio raised to the n minus 1. And now let's find the 7th term. That would just straight up be, since it's not a fraction, for the calculator, 5 raised to the 6th power times 3. And I'll just write down here. That results in 46,875. All right. I can see that the first term is 5, but now I've got to identify the common ratio. Notice that the signs are changing from positive to negative and back and forth. So I know my common ratio is going to be some negative number. I also see that my values of my terms, the further I go to the right, are getting smaller. So probably going to have a fraction here. So take these first 2 terms, take the second term, divide it by the previous term. I can't reduce that. I think that my common ratio is going to be negative 1/5. If you took these 2 terms and took positive 1/5 and divided it by negative 1, that's the same thing as saying negative 1/5. So writing the formula, first term, common ratio raised to the n minus 1. Find the 7th term. Again, if you want to get a decimal, take negative 1/5 in parentheses, raise it to the 6th power, and then multiply it by 5. So that decimal is 0.00032. I think it's worth just kind of making sure that we would know how to handle it if we wanted a fraction answer. So I'm just going to come over here. So I take negative 1/5 to the 6th power, remembering that you take negative 1 to the 6th power, so that's positive 1, and then you find 5 to the 6th in the denominator. So I go to my calculator, use that to do a little bit of work. So 15,625. Okay, this is more manageable because if I want to leave my answer as a fraction, I know that 5 divides into this number. So if I divided 5 out here and divided 5 out here, I would just go back to my calculator, hitting divide 5, and I would get 1 on top and 3,125 in the denominator. So if the request is that you have a fraction, that might be a way to tackle it. I would confirm, I'd go back and I'd do 1 divided by 3,125. Make certain that you do get that decimal equivalent right there. All right. All right, moving on. Now, similar to what we did with the arithmetic sequences, we're going to be interested in summing the first n terms of a geometric sequence. So that formula is big S for sum. N stands for how many terms are we going to be adding together. Okay. And this is just summation notation that is just another way to say we're summing a bunch of terms from 1 to n. But this is the formula right here that we're going to be using. And again, that's another formula that you could have on a sheet of paper for this test 4 to assist you in finding some of the answers to the test questions. All right, so the sum of the first n terms is equal to the fraction. And in the numerator, the first term times parentheses, always 1, minus the common ratio raised to that same n value, divided by, and then in the denominator, just 1 minus the common ratio. Now, this is going to get kind of tricky with your calculator, so just kind of be aware of that. That parentheses sometimes help and sometimes hinder us. All right, number 8. Find the sum, okay, of the first 12 terms of a geometric sequence. When you see sum geometric, that connects you to this formula right here. Okay, so to find the sum of the first 12 terms, we need to know the first term, and we need to know the common ratio, and we need to know the number of terms. So the sum of the first 12 terms, remember this is n is 12, a sub 1 is 3, but we have to find r. So what's the number you're always multiplying by to generate the next term? Looks like it's 2. You could check real quick. 6 divided by 3 is 2. 12 divided by 6 is 2. 24 divided by 12 is 2. So yes, the common ratio is 2. A sub 1. All right, they want me to give that. That's 3. Common ratio, oops, is 2. And n is 12. So the sum of the first 12 terms, I see 4 of them. I could keep, generating the first 12 and then going on my calculator and doing it, but this formula will get the answer for us. So S of n, we can kind of ignore this, is equal to a fraction. The numerator starts off with a sub 1, parentheses, and then it's 1 minus, I would do another parentheses for the common ratio, 2, and I'd raise that to the 12, making sure you know that this last parentheses on the outside. And in the denominator, 1 minus the common ratio, 2 again. Okay, so I know the denominator is easy. That's just going to be -1. The challenge is going to be with the keystrokes on the calculator in the numerator. So for me, I'm probably going to do what's inside here first and then go back and multiply by 3, but be careful. So inside first, 1 minus, and then here I would do a parenthesis, 2, close your parenthesis, raise it to the 12th. There it is. So it looks like I'm doing 1 minus 2 to the 12th, and that's all I would do. I wouldn't even do another opening and closing parenthesis here. Press enter, go back and multiply by the first term, times 3. And you're going to get that value, -12,285. But to finish this up, a negative divided by negative is positive, and we don't need to show that 1 down there. So that's the sum of the first 12 terms. All right, so you might want to try number 9 on your own and then come back and see how you did. First term is 4. I'm adding 11 terms, that's what n is. The common ratio, I have to figure out what am I multiplying by. So it looks to me like I'm multiplying by a negative number. And then to go from 4 to 12, I multiply by 3. To go from 12 to 36, I multiply by 3. And because it's an alternating geometric sequence, yes, it's going to be -3. So how do I find the sum of the first 11 terms? I see 4 of them. Okay. So the formula up above, first term, parenthesis, common ratio in parenthesis. This is important when that's negative. Raised to the 11th power and then close that parenthesis. Denominator is 1 minus r is -3. Okay, denominator 1 minus -3 is 4. And then all calculator work again here. I would do what's in this big parenthesis, but not using the parentheses. I do 1 minus, open a parenthesis, -3, close your parenthesis, raise that to the 11th. And don't forget to go back and multiply by the 4. I see that both these numbers are even, so at least I know 2 will divide into both of them, but I'm going to go ahead and see if the numerator is divisible by 4. It is. If it wasn't, I'd probably just divide out the 2 and leave my answer as a fraction. I think 10 and 11 are the same. It's just the presentation of the problem is that we're in summation notation. So we still have to find the first term, the common ratio, and the number of terms in order to find the sum by using this formula right here. Okay, so I'll probably find the first term. So let I be 1. So that's going to be negative 12 plus, when I is 2, that's going to be negative 3 squared or 9. 9 times 4 is 36 plus, if I let I be 3, I would do the power first. That's negative 27 times 4, I think is negative, what is 27 times 4? I should know this. 108 plus dot, 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 dot until you get to the 7th term. I could find that if I wanted to, but for this formula, I don't need the value of the 7th term. I think I have everything I need. So I need a sub 1, which is negative 12. I see the common ratio is negative 3. That's usually the base of that exponent. And my n value is 7. Okay, the denominator is 4. And multiply by negative 12. Can I hit the negative first? Yeah, on this calculator. All right. Let me see, I know both the values of the numerator and denominator are even, so 2 will at least come out, but why don't I go ahead and try and see if that divides by 4? Oh, it does. So that's your final answer. Okay, for 11, I'm going to generate a few terms. So if I is 1, then I add 1, I get 2. So this becomes a half squared plus, I'll clean it up in a minute. If I is 2, then I have a half cubed. So this is the first, the second. Let me plug in 3. 3, that new exponent is 4. I see the pattern, dot, dot, dot. Okay, so what's the first term? So we got to square this fraction, so that becomes 1/4. So our common ratio is, notice that we keep multiplying by another half. That's why the exponent is increasing, so that's a half. And the number of terms that I want to add would be 6. Okay, so let me come back here and kind of work this out. This is going to be 1/4 plus 1 cubed, 2 cubed is 1/8, 1/16 plus dot, 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 dot. I hope they want a decimal answer on this one because I'm not going to find a common denominator with this. I'm going straight to a decimal. So let's add the first 6 terms. So 1/4 is your first term. 1 minus 1/2 raised to 6, close parenthesis. 1 minus a half. Okay. 1 minus a half is just a half. And then let me get the numerator. I think it's going to be an ugly fraction. Times 1/4. Make sure you put 1/4 in a parenthesis. Ooh, that is ugly. I think that's enough decimals. And then I'm going to divide that answer by a half. So divide it by, and then make sure and do parentheses again. Hopefully I'm on the screen. There we go. Yep, that's what I got. To the requested number of decimals, whether it's 3 or 5 or whatever, I'll just go to 3 decimals. So that's our answer. Okay, and last objective. I know it's running long. I like to keep it under 30, but just want to finish these up. So the general term of a sequence is given. Okay, got it. I'm looking at them. Determine whether the sequence is arithmetic, geometric, or neither. If the sequence is arithmetic, find the common difference, D. If it's geometric, find the common ratio, R. Okay, well, I think the best way to do that is just maybe generate a few terms to kind of inspect each term to see if we can see a pattern. So for this general term, I'm going to let A sub 1 or N be 1. So N is 1 here. That's -2. Just generate enough terms to where you can kind of see if there's a pattern or not. If N is 2 here. So 2 minus 3. Looks like I'm always subtracting the same number. That's -1. N is 3. 3 minus 3 is 0. Now I'm going to do one more. The fourth term, 4 minus 3 is 1. So when you look at the progression of these terms, I see that the terms are getting bigger by 1 each time. So I would say, yes, this is arithmetic with a common difference of 1. You almost want to say the common difference is -3, but the formula is just a little bit odd. Okay. 13, before I get started, looks to be geometric, and I bet the common ratio is a half. But let's just confirm that by generating a few terms. So 1/2 to the first. Don't really need those parentheses. When N is 2, the exponent is 2. 3 would just be a half to the third, etc. So to go from here to here and here to here and this term to that term, I'm always multiplying by a half. If it's better for you to view these expanded, like that's a half, this fraction would be a fourth, this fraction would be 1/8, because 2 cubed is 8, and this fraction would be 1/16. If it's better for you to see that the denominators are getting multiplied by 2, but the numerator stays 1, then look at it in that format. But this is geometric, and its common ratio is a half. Okay, and the last one. N is 1. 1 squared minus 3. 2. 2 here, 2 here. 2 squared. So 4 minus 3 is 1. 3 squared. That's 6. Well, right away I can see that to go from -2 to 1, I'm adding 3. But I can't add 3 to go from 1 to 6, so this is not arithmetic. And then I'm going to test to see if there's a common ratio. So 1 divided by -2 is -1/2, but 6 divided by 1 is not that -1/2. So this is neither. Okay. So that concludes geometric sequences.